Welcome friends, myself Mr. Amruti from Kankoli College, Kankoli. This is my first video for the mathematics students of class 12 Science and Arts of Maharashtra State Board. As you know, the syllabus of mathematics is divided into two sections, section 1 and section 2. We shall begin our discussion with section 2. The first topic in section 2 is differentiation. See, differentiation is not new to you. In 11th standard syllabus, differentiation is included. But then you just have studied the basic concepts of differentiation. This year, we shall see differentiation in details. We shall start our discussion of differentiation with the meaning of derivatives. We understand derivative as a rate of change of a function with respect to some variable. For example, dy by dx, as we denote derivative of y with respect to x by dy by dx is derivative of y with respect to x, which means it is rate of change of y with respect to x. For example, if you consider the velocity is derivative of displacement with respect to time, because normally when we see velocity is defined as rate of change of displacement with respect to time. So rate of change of displacement suppose is x, displacement is suppose x, and time is suppose t. So what I mean is, there is a particle moving with certain velocity v, and at time t its displacement is x. Then how v is written is, v is dx by dt. Velocity is instantaneous velocity. V is an instantaneous velocity. It is actually the derivative of displacement with respect to time, dx by dt. So thus velocity is, like we say, velocity is rate of change of displacement with respect to time. It means it is derivative of displacement with respect to time. Similarly, we can consider acceleration. Acceleration, you must be knowing, acceleration is, so here we discussed velocity, how velocity is considered as a derivative of displacement with respect to time. Similarly, we consider acceleration. Now, how do you write acceleration? Acceleration is suppose denoted by a. It is nothing but rate of change of velocity with respect to time. So rate of change of velocity with respect to time, which means derivative of velocity with respect to time. So acceleration is derivative of velocity with respect to time. So we have seen these velocity, acceleration, etc. in physics, but then we didn't consider them as derivatives, etc. We understood them as rate of change. Velocity was considered as rate of change of displacement with respect to time, and acceleration is considered as rate of change of velocity with respect to time. But they both are derivatives, and they are derivatives of, respectively, if you consider velocity, then it's rate of change of displacement with respect to time, and therefore it is derivative of displacement with respect to time. And acceleration is rate of change of velocity with respect to time. Therefore, acceleration is derivative of velocity with respect to time. So now let us discuss the geometrical meaning of derivatives. We just discussed the derivative as a rate of change of one variable with respect to another variable. Now it's time for geometrical meaning. For this, I need a graph. This is a graph of the function y equal to fx. Any graph, you can say. This is generally drawn one. Then consider one point P having x coordinate a, and y coordinate obviously found from its x coordinate. Put x coordinate here, you will get f of a as y coordinate. So the coordinates of point P are a and f of a. Coordinates of point P are a, f of a. X coordinate is a and y coordinate is f of a. Similarly, there is point Q, which is taken with x coordinate a plus h, and y coordinate you can see is f of y coordinate is f of x coordinate, which is x coordinate is a plus h. y coordinate is f of a plus h, which you will find here on y axis. So there are 2 points P a f of a and Q a plus h f of a plus h on this curve. Now join this segment PQ and extend it so that you can see this secant PQ. Secant PQ is understood here. Now the slope of any line whose for which you know 2 points on it, suppose one is x1 y1, other one is x2 y2, then the slope of that line is given by y2 minus y1 upon x2 minus x1. So in this case, the slope of secant PQ will be seen as y2 minus y1 upon x2 minus x1. So what is y2 minus y1 here? It is f of a plus h, which is y2, minus this y1 divided by x2 minus x1. x1 is a. If you simplify this, you will find this a cancelled with this a, and you would end up with f of a plus h minus f of a upon h. This is the slope of secant PQ. Slope of secant PQ is f of a plus h minus f of a divided by h. Now see this graph again. What we shall do now is we shall make this h, this is h, this is a, this is h, this is a plus h. So if you make this h, this is originally h, this is h. If you make this h little bit smaller, means I will take this much h, for example, this much only, then a plus h will be written here. Then what will happen to point Q? Point Q will come down. Here will be Q. Then this will be f of a plus h. F of a plus h will come down. Here f of a plus h. So Q will be having the same coordinates, a plus h, f of a plus h. Symbolically same coordinates. The value will obviously change. But secant PQ. So what happened is, we took this h smaller than the previous one. If you make h smaller, Q comes closer to P. P is there, Q comes closer to P. And then secant PQ will look like this. If you make this h even smaller, Q will come very close to P. Secant PQ will be drawn like this. You can imagine this. Just keep on imagining. And if you make h very small, means in limiting conditions, if you take h tending to 0, Q will come closer to point P, means Q will tend to P, and secant PQ, what will happen to secant PQ in these conditions? If h is very small, that means h tending to 0 is a limiting condition. So if h tends to 0, Q will tend to P, point Q will tend to point P, and secant PQ will turn into tangent, see this, tangent at P. How would it look like? If h is very small, Q will come close to P, even closer to P, and then finally you will find this secant like this, and finally you will see secant as a just tangent at P. So with this condition, h tending to 0, secant PQ turns into tangent at P. So let us apply this limiting condition on this relation, limit h tending to 0. Apply this condition, limit h tending to 0 on both sides, limit h tending to 0. Okay. Now read this again. Limit of slope of secant at PQ as h tends to 0 is limit of f of a plus h minus f a upon h as h tends to 0. This limiting condition h tends to 0 is equivalent to Q tends to P. So Q tends to P. That means secant PQ tends to tangent at P. So I can write this whole left side as slope of tangent at P. Slope of tangent at P. Secant PQ will turn into tangent at P due to this condition. And there, what do you know about this? Limit of f of a plus h minus f a divided by h as h tends to 0. In 11th standard you have studied this. This is nothing but f dash a. That means derivative of function fx at a. And what is x is equal to a? Point P is referred to as x is equal to a also. So instead of writing slope of tangent at P, I may write slope of tangent at x is equal to a. Point P means point x is equal to a. Point x is equal to a means point P. So you should understand that whenever I write P, it means that I am talking about the point whose x coordinate is a. So I may read this everything as slope of tangent at x is equal to a. To this curve is nothing but f dash a. So which is nothing but derivative of function fx y is equal to fx at x is equal to a. So derivative of a function y equal to fx at x equal to a is nothing but slope of tangent at x is equal to a. So now we discussed the meaning of derivatives in two ways. We discussed derivative as rate of change of one variable with respect to another variable. Considering function suppose y is equal to fx, then I may say dy by dx is rate of change of y with respect to x, which is also sometimes denoted by f dash x. Dy by dx or f dash x are the two notations that we use for writing derivative, dy by dx or f dash x. In these both ways we can write a derivative of a function y with respect to x. F dash x is derivative of fx. Fx is y only. So these are both of these mean the same thing. The derivatives other meaning, like I said, other meaning is geometrical meaning is the slope of tangent. That way we can consider derivatives in two ways. Now what is differentiation? Differentiation is an operation of finding derivative. Just that much. Differentiation and derivative, the terms look different, but what is the exact relation between them? Differentiation is the operation of finding derivative. Means differentiation is operation of finding rate of change of y with respect to x. If you are finding derivative dy by dx, then I may say differentiation of y with respect to x is finding derivative of y with respect to x, means finding rate of change of y with respect to x. Let us discuss the two notations of derivatives, f dash x and dy by dx. Both these notations mean the same. Sometimes we write derivative of y with respect to x like this, dy by dx, and sometimes we say that derivative of y is equal to fx is f dash x. So conveniently, whichever form which we require at a certain time is used. Otherwise, they both mean the same thing. What is the exact similarity, or how do you see the similarity or equalness between them? See, this graph will tell you something. This point P is there, having coordinates x and f of x. I have taken x coordinate x, so y coordinate is f of x. So that way this is f of x. Similarly, there is point Q whose x coordinate is x plus h, so y coordinate is f of x coordinate, which is f of x plus h. Now by first principle we write f dash x is equal to limit f of x plus h minus fx divided by h as it tends to 0. This is by first principle. Now how do you see this? Suppose this h is replaced by delta x, because h after all is a small change in x. So let us denote instead of h instead of h we shall use the notation delta x. Delta x or h both mean the same thing. They mean the small increment in x. Similarly, if you see, if you make this delta x very small, what will happen to q will also come very close to p. By that time, what will happen to y coordinate? Y coordinate is initially suppose y. Now it becomes, the difference between them is initially delta y. So difference between x coordinates is delta x, difference between y coordinates is delta y. So if you now see the coordinates of point P are x, y, and y, the coordinates of q are in new terms x plus coordinates of q are x plus delta x delta x, and this is y plus delta y plus delta y. So in new terms, now f of x plus h will be replaced by, see this, dy by dx is f dash x means the same thing. Limit h tending to 0 will means delta x tending to 0. F of x plus h means y plus delta y, minus f of x means y, upon h means delta x, or you can see this simply as limit delta y by delta x as delta x tending to 0. You can finish it like this: limit delta y by delta x as delta x tending to 0. So you can understand dy by dx as limit delta by delta x as delta x tends to 0. You can remember this formula. In proofs of the rules of differentiation, we shall use this formula. And this f dash x is something which you have studied in 11th standard only, first principle of derivatives. So this gives you this easily. That way we shall use the notations f dash x and dy by dx whenever they are required. Sometimes we will be using dy by dx, sometimes we will be using f dash x, but they mean the same thing. You can see in the graph. Have a look at this graph. Just notations are different. Otherwise, the idea or the concept remains the same.